Alright, in this video I want to look at something called a self-avoiding random walk. And as you can imagine, it's a random walk, like we have defined here, for example, but where you're not allowed to visit a previously visited point. And now to get this running in kind of a reasonable time, you're going to need something like a set type, like a hash table, or what's called a set in Python, for example. Now the bad news is that there's no built-in set in C. The good news is that a few years ago I did advent of code in C, and to do that I wrote a set implementation. But before we get to that, let me just do this kind of backup thing. So let's copy this and call it continuous walk, let's say. And then let's have a look. So I already copied the code from the HashSet here, so we can just use that. And now for this I want to use a grid again. And that means we can get rid of this stuff. And now let's say we're gonna make a new point, which we'll have here in the generation code. We'll make a new point like this, which is a copy of the old point. Then we will update that. Well, there's no reason to do that. Just do this. There's a copy of the old point. And then here we also need to make a set. Okay, so now we're getting to the self-avoiding part. So the way my hash set implementation works is a little bit weird. You have to do something like this. First you have to define the type. So we want it to be a set of points. So we write point. Then you give your type a name. So let's just call it a PointSet. Then you need an equality function, which is named the type underscore equality. And for our case, it's just are both the points equal? Let's call this point 1 instead, and this one point 2. So point 1, point 2. Point 1, point 2, and then you define this hash table, hash set implementation. I think I might remove that at some point, and then you just include it. And then using macros, it will generate a type called PointSet that has a bunch of nice to use functions that you would expect from a set. Okay, so let's make a point set of visited points, and you have to call a function that creates. It's called create point set. So now we have a point set. Let's go down here and remember to free the point set. Okay, and here when we create it, we also need a list of buckets. So in principle, probably a good choice is like twice as many steps as we're gonna twice as many points as we're gonna make. Twice the number of points that we're gonna make. Because that will reduce the chance of hash collisions, hopefully by enough. The more hash collisions you have, the slower the performance will be. So let's try to avoid that. But of course, you trade it. You pay in space instead. Okay, so now how does it work? So we need to check here if let's do this, and let's say do we need to include, let's just do it for good measure. Okay, so let's have this one already. Let's call this visited points instead. So now let's check. So we'll say visited equals is this point a member? So I'm looking over here, I have this lm function that takes a table and a type and returns Boolean. So if it's already visited, then let's say if it's not visited, what will we do? We will say, we will insert and we will also break out of the switch, but yeah, let's go with that. Now, if it's not visited, what will we do? We will first let's revert this. Then in C, if you don't write break, it will fall through. So we'll fall through here, and then we can go through the same thing. And here we have to revert that. And again, we'll fall through. We'll say visited. If not, then this. And otherwise we revert it. Same thing here. Great. And then, oh, we need this one up here. Then if not, let's just revert it so it's symmetrical. But okay, so what happens is if we had visited a point, then we will just fall through. And it's kind of biased in the sense that if you try to go right, then it might try all of them, but if you try to go down, it will not fall back and try another one. So that's unfortunate. How could we get it to try all of them? I don't know. But I guess let's say default. Then we really want to break out of the loop because there's no more we can do. So we can even use go-to. That's one way to break out. But now it's because we might end up in a point where we visit all the points around the current point, and then there's nothing to do anymore. So in that case, we might not generate all these steps, so we also need to return how many did we actually generate. Let's call it a local count, and we can do that down here, local count, and then here we'll set count equals local count. Okay, now how do we go back? We can say something like, how many have we tried? And then in each one we'll say plus equals 1. And then here we can say if we haven't tried for, if we have not tried for, then we'll go to the start of switch, let's say. They say you're not supposed to use goto, but today I just feel like it. Start of switch is here. And actually, let's see, not equal to 4 is not good enough. It has to be if it's less than 4, because let's say we start here, then it'll be 1, 2, 3, it will fall through, it will say not equal to 4, then we'll go to the start, then it'll be 4, 5, 6, 7, and then it'll say not equal to 4 still, and it will just be an infinite loop. So it has to be less than 4. And then you will actually try everything. Actually, we need another thing, which is that if we end up here, we have to say that R is 0, which means that we will just try everything from the top. Because otherwise, when we hit the switch again, it will just end up where it started before. So, okay, I think this is a decent solution. Now, let's say we're also going to need to keep track of the counts. So let's allocate some integers. And here we'll say, sure, right into that. And now instead of number of steps, it has to be counts k minus 1. And then we can just try to run that. Now let's see how badly it will fail. It already failed up here, which is because it's not called HashSet. And what did I do? Okay, it's called HashSet. HashSet. And that didn't work either. It's because it's not .c, it's .h. Let's actually go and change that in here in the documentation. That's a little bit unfortunate. But the rest should be fine, at least I remember it that way. Okay, so here we go. That's zooming way too fast. Let me change the zoom speed. Float zoom speed. Let's make it half of that. And run it. Oh, everything is way faster than. Is my CPU just running extra fast today? Interesting. Probably it's because there's way less points. Another thing we should do in Raylib is to set the target FPS. That will probably help a lot. Yeah, it helps a ton. Because otherwise the frame rate was just unlocked, I think, and that made it go super fast. Okay, another thing we should do here is let's draw a small circle at each point. Maybe slightly larger. How about this? No, how about this? Okay, so that looks good. Let's change this one to 1. Okay, so you can see it kind of... First of all, it looks like it has visited the same point twice, which is of course because we forgot to add the starting point. Yeah, the funny thing is it quite quickly dies. Why would it do that? See, it stopped here. Why did it do that? That's very weird. Is it debug time? I think it's debug time. So let's check out what we built it with. We don't build it with debug information right now. So let's add that. Let's build it one more time. And now let's, is this not tmux? No, it's not. So let's start a tmux session because otherwise I don't know how to work with this. Okay, so now it should be built with debug information, which it is. So let's run, let's try to run the debugger. Source file is more recent than executable. Okay. So here we have the source. And let's see what happens when... Oh, I didn't want to do that. Fuck. So let's step into this guy. And let me see what's the line number. So I want to see what happens in line 84. Okay, so let's look at what this one is. It's 2, which is good. So what is R? R is 2. That makes sense. So the next one is here. The next one is, we go back, switch on that. Okay, so that was fine. Let's try to continue. We have tried a 1. Okay, that was also fine. Continue. Maybe we should just say display this one. I am just waiting for when it fails. Okay, so now it should fail. What is count? Local count rather. So it only made 82. So now we should go to end. Which is fine. We do that, we do that, we do that. Let me have a look at count 0, 82. That's good. And now everything else should be fine. Let's try to print points 81. It's just shit, so points 0, but the 81th in that list, and 80. Yeah, it's hard to tell. Let's just try to continue, then we should get the screen here, and we can see that for some reason, I think this is the starting point, and then it goes, and we end up here, and it thinks that it cannot go up. It's entirely possible there's some kind of bug here, but I don't think so. I don't think so. Is there another way we can test this? So let's say we're here where it fails. Then isn't there a way to loop over the table? Yes. So we can say loop table, and it's the visited points. And we can just call it the current node, and then we need some kind of body to apply. And let's actually start with doing this. And let's see what we can get out of that. So let's that didn't work. Because how is it works? It is relying on this linked list under the hood. It is supposed to be value, but what's the problem then? Node name. Now maybe at this point I just copy this code because I don't see a problem with the code itself. So it's probably just me that's bad at writing C macros. Let's remove those guys, do this. And it's gonna be visited points. Points. And that's all good. What do we want to do? We want to say print f. Now it thinks we have to say data, but I'm pretty sure this is, and then I have to remember what the list here. You know what? Let's not do this. Let me try. How is it? Is it like this? There is some way to get it to print the preprocessor output. Okay, it's capital E. So then we have to include prelib. Right, so let's get it in here. Let's call it preproc.c. And then we'll take a look at the function that we have called random walk. Okay, so here we go. So this looks all right. Visitor points is equal to 0. Then we continue. Otherwise, so here is a problem. Somehow the macro expansion went wrong. This guy. Okay, I don't want to deal with that right now, so let's just try to see what the linked list is doing. Linked list name is underscore. PointSet. Table list maybe. Okay, that should do it. And this is in preproc, so we actually need to move this stuff to main. There we go. Okay, so now it runs, and it also printed a bunch of stuff. But let's get the debugger in again. There we go. Break in line 88. Let's run this. And now we're here. So let's break in 97, I guess, and we'll go there. And we have this problem. Okay, you cannot really print in a nice way. Let's do another thing. Let's say current x is node value x. Current y is node value y. If current x is equal to p.x plus 1, and that will do one thing. If current, let's actually do this. So if the difference is 1 between the x's and not 0 between the y's, or the other way around, then we're going to print it. Let's also here print current, just to see that it's correct. So it looks correct. We have -3 and 2, and there's one downwards, there's one to the right, there's one upwards, and there's one to the left. So let's zoom in and see. It's still not correct. So where is -3? This is 0, 0, so 1, 2, 3, and 1, 2. Okay, so it's just that it's not drawing the last one. Which is funny. So of course, okay, it has to start at 1. So it's kind of the same problem as before. So let's zoom in now. And now we see it's correctly stopping. All right, so finally. Let's comment this out now because it was difficult to write. This thing is again working correctly. Here we have the endpoint, which is trapped. And let's try to do 5 runs again. Let's change up the alpha a bit. Alpha, maybe we just make it 255 again. So like the main difference is that you don't get very big walks because it eventually it will get trapped like this. And maybe you could do some kind of backtracking to make it more interesting. But I think that's it for this video. So I will see you in the next one.